Assalamualaikum warahmatullahi wabarakatuh. My name is Solehin Bin Mohd Taib1725459. My supervisor is Dr. Motakabber, and the project title for my FYP2 is Design of Hybrid PV Wind Renewable Energy System using Matlab Simulink. For presentation, I will cover the intro, problem statement, objective, literature review, methodology, result and discussion, and also conclusion. As we know, fossil fuels are currently the primary source of energy around the world. However, fossil fuel is limited and it brings negative effect to environment. So many countries have turned to renewable energy source such as wind, solar, and biomass to overcome this. And there's abundance of renewable energy available around us, and at the same time, multiple renewable energy will available at once. And for this, we need a hybrid renewable energy system which can share the load in order to optimize the power available. However, the renewable energy has unpredicted nature, such as wind energy. The wind is not continuously blown all day, and the speed of the wind varies. And for the hydropower, the water precipitation level fluctuates every year. So to overcome this, hybrid renewable energy system is recommended, which it combines multiple renewable energy to optimize the energy productions, and it can fulfill the energy demand. For the problem statement is the unpredicted nature of the energy can cause drawback, and the load demand varies. So sometimes the load in the night is lower than the load in the day, so the energy needed to produce it will become a problem for it. And the third one, there's a need for system that is simple and easy to implement, which has high performance and has reasonable cost. The objective of the FIP is to study the basic principle and feature of the power management system for multiple power source through literature review. Second one is to design a simulation of PV, wind, and PV wind generator system and verify the design with theories. The third one is to simulate and verify the performance of the hybrid PV wind system with benchmark paper. For the table of summaries, the first method in literature review is Prof and also method. The advantage of this method is simplify the complexity, it is cost efficient, and it has wide chance of improving. The disadvantage is there's oscillations at fast varying environment, and it is difficult to control the step size. For virtual impedance method, it's great operation for the reactive power sharing. It is great for nonlinear and abelian load. However, the additive coefficient is compared to required and difficult to design a high efficiency algorithm. And for the hierarchy control, there is no bandwidth required to recover the voltage and frequency setted value. It simplifies the model of the dynamic and microgrid. However, the disadvantage is the communication delay is low, bandwidth, line, and the algorithm are complicated in this method. For methodology in my FIP is first I identify the PV array and wind turbine parameter from literature review. Second one, I design the PV generator, wind generator, and PV wind generator, which I design it both in the same system and combining both generator to create a hybrid PV wind generator in Matlab Simulink. Then I find out the elements simulation of the hybrid PV wind control system. Second one, after that I obtain the result from the simulation and validate the result based on the theory on the literature review. And lastly, I compare the result with the benchmark paper. This is the design of the PV solar that I create in Matlab. The design used tube and observe technique. We can see here it is implemented down there. This is the design of wind turbine generator. In this design, we use PMSG, permanent magnet synchronization generator, because The wind turbine produces AC current, and to process it we use PMSG, and then the AC current is converted into DC current because in the design the load is considered to be DC. This is the hybrid PV wind design. In this design there is DC-DC buck converter for both PV and wind generator because the load that we use need to be stepped down because the load in this design considered to be low, so the power need to be stepped down. And as we can see here, the PV and the wind generator share the same load, where at the left corner we can see here the DC-DC buck converter at the end combined, and the load are shared, and the power of the combined hybrid PV wind are calculated at left side here. And for the result and discussion, this is the result of PV power generations. For the input of the PV, the irradiance is changed from 100 to 1000, and we can see here the power increase from 1000 watt to 1500 watts because of the changing in irradiance. And this is the power output of the wind power generator. The speed of the wind is set to be 8 meter per second and then change to 12 meter per second. At 8 meter per second we can see the power output is about 125, and when it changed to 12 meter per second the power output become 250. This is because the wind power increase when the speed of the wind increase. Lastly, this is the power output of the hybrid PV wind. As we can see here, the power is increasing from 45 to 65, and then it increased to 70, around 72 watt. And for this power, we can see it is smaller compared to PV and wind generator because the PV wind power is measured at the DC load, and the input of wind and irradiance are similar with the PV design and wind design. And the power output here smaller is because of the DC-DC buck converter which is implemented in the design, where the DC-DC buck converter step down the power. However, the pattern of the power output is verified with the input and of the wind and PV, where if we input the increasing varies put, the graph will be look at this and give the same pattern as this. And as we can see here, this is the on the left one is the benchmark paper, and the right one is the simulation that I made in the Matlab. And we can see it has the same pattern for where for wind the input increase and then decrease and increase back, and for the PV wind power the input is varies, and because it is the additional of the power from PV and uh, wind generator. And for conclusions, the design of PV generator and wind generator are managed to be constructed in the Matlab Simulink. The performance of the hybrid PV wind systems are separately verified theoretically, and it validates with the comparison of previous study. And for the future work of this project, we can create a control for the hybrid combinations of the PV wind, which it can improve the performance of the hybrid PV wind system, and this control can be added for the future work. That's all. Thank you.